The fact that the proportion of heads in many tosses eventually goes to 0.5 is guaranteed by the law of large numbers. So that's what I was talking about with the applet. The more repetitions we had a much more consistent proportion for the number of heads, and it was very close to 0.5. It's not always going to be 0.5 exactly, but it's going to get really close, and it's going to stay constant and close to that number. When we had a few number of coin tosses, the variation was very big. We were down below 0.5 quite a bit. We were up above it. So this law states that if we observe more and more repetitions, so there's your large number, of any chance process, the proportion of times a specific outcome occurs approaches a single number. So in the case of tossing the coins, we were approaching that 0.5, the proportion of heads. So the actual definition of probability, the probability of any outcome of a chance process is a number between 0 and 1. I don't know how, actually I do know how many years. I've been saying that for almost 6 years, and I still get kids every year on the test. I'll throw an answer on a multiple choice that's not between 0 and 1, and kids they'll choose it. Probability has to be between 0 and 1. If it's greater than 1, that's not a probability. If it's less than 0, that's also not a probability. They fall in between 0 and 1 only. So it's a number that falls between 0 and 1 that describes the proportion of times the outcome would occur in a very long series of repetitions. So that's that whole law of large numbers. Outcomes that will never ever occur have a probability of 0. So the probability when I toss a coin that I get a foot instead of a head or a tail is 0, because there is no foot side on a coin, a regular coin. I'm sure there are some coins out there with feet on them. The outcome that will always occur has a probability of 1. So what is the probability that I'm trying to think of one. I can't think of one right now. What's the probability I'm going to eat dinner tonight? It's 1, because I am going to eat dinner tonight. I can't think of another common one. What's the probability, I guess you could say, sticking with the coin toss, what's the probability that you will get heads or tails? It's 1, because you're either going to get heads or you're going to get tails. So in the homework tonight, you're going to have questions that will have you explain what probability means. So we're going to do an example like that. And then they're going to ask you to apply that probability to a certain number. And the biggest thing you need to remember is that the probability is talking about what's going to happen in a very long series of repetitions. So if they ask you to take probability and apply it to 5 repetitions, we can't assume that something's going to happen at 0.2 or 20% of the time in 5 repetitions. That's not a huge enough or a long enough series of repetitions to assume something's going to happen. So down below, we have an example question. It says, according to the Book of Odds, and yes, that is a real book, it's not made up, The probability that a randomly selected U.S. adult usually eats breakfast is 0.61. So first thing we're going to do is explain what it means in this setting. And then part B says, why doesn't this probability say that if 100 U.S. adults are chosen at random, exactly 61 of them usually eat breakfast? So first we're going to explain what it means, and then we're going to explain why we can't say 61 out of 100 eat breakfast. So the biggest thing when you're explaining probability is to take that law of large numbers, or the very long series of repetitions, into play. So I always like to just start by saying in the long run, or you could say in a long series of repetitions, but I shorten it. I'm lazy. I like to say just in the long run. And that is common terminology when describing probability, to say in the long run or short run. Both of those mean long series of repetitions or a short series of repetition. That way you don't have to write so many words. So in the long run, we would expect notice I'm saying expect, not that it's for sure going to happen. We just expect that the proportion of U.S. adults who eat breakfast to be 0.61. Now, this is got to be like an English teacher's least favorite answer, because we pretty much repeated what it said. We just added that in the long run we expect this to happen. That's what a probability is telling you, is that in the long run this is the expectation. Can we say for sure it's always going to happen? No. I could, in that applet, do 1,000 coin tosses and still not have my proportion be exactly 0.5. It's going to get really close to it, and it's going to stay close to it, but it's not always necessarily going to be exactly 0.5. See here at 510, I'm at 0.51. So it's our expectation, but it's not always going to be reality. And I think that's one of the hardest things with probability, is that we think it's supposed to happen, it's supposed to be the reality, when it's not. It's not always going to happen that way. So then the other part of the question, like I said, they're going to ask you to apply the probability to a number. So in this case, they say, why doesn't this probability say that if 100 U.S. adults are chosen at random, exactly 61 of them usually eat breakfast? So 100 can seem like a big number, except for we're talking about it in terms of the U.S. adult population. And just randomly picking 100 U.S. adults is not enough people to compare it to the whole population and say, okay, we expect it to be 61 exactly. We can't say that. This is what would be called a short run. It's not enough repetitions to say something is going to happen exactly. So that, you know how they tell you to be careful of those, what are the words? Like never, always. What are those words called? I can't think of it. So, we can't say for sure what is going to happen in the short run. So if we were to randomly pick 100 US adults, we could end up with 68 out of the 100 saying they ate breakfast that morning. You could end up with 42 out of 100 that said it. Yes, we could end up with 61 out of 100, but we can't guarantee it with such a small sample. So we want to avoid statements like exactly always. Those kind of statements don't work well with probability. Any questions before I flip to the next page? So this one is just kind of helpful for you to see what different proportions mean in terms of the probability. So probability is a measure of how likely an outcome is to occur. So we're going to match one of the probabilities that follow with each statement. Thank you. So the outcome is impossible. It can never occur. So would that be 0, 0.01, 0.3, 0.6, 0.99, or 1? Throw it in the chat or unmute yourself for me. Oh, come on, I told you this one already. What's the probability of an outcome that is never going to happen? Something that's impossible. Say it again, Ian.
It was Owen first.
Oh.
0.
0. Thank you, sir. Ian, is Cody with you?
Nah, I have no idea where it is.
Gosh. Okay. All right.
I texted him, sorry.
Okay. Rude. So rude. All right. So B, this outcome is certain. It will occur on every trial. Which one is that? We already used
1.
0. Thanks, Owen. 1. This outcome is very unlikely, but will occur once in a while in a long sequence of trials.
0.01.
Thanks again, Owen. 0.01. And then the last one, the outcome, ooh, sorry, I need to learn to proofread. Occur does not have an E at the end. This outcome will occur more often than not.
Might be 0.6, although it could technically be 0.9.
Perfect, Owen. It could be 0.6. That happens more often than not because it's greater than 50 or 0.5. And that one also happens more often than not because it's also greater than 0.5. All right. So, law of averages. Anybody ever hear of this before? Law of averages. So this is where I wanted Cody. I don't know why, but baseball players tend to say law of averages more often than any student I have ever heard. I've even had baseball players argue with me about the law of averages. So before I answer whether it's real or not, we're going to look at the example. A few years ago, an advice columnist published a letter from a distraught mother of 8 children. It seems that she and her husband had planned to limit their family to 4 children. When all 4 were girls, they tried again and again and again. after 7 straight girls, I should say even, not ever, even her doctor had assured her that the law of averages is in our favor 100 to 1. Is it true that since in the long run the probability of having a boy is 0.5, that the woman and her husband are more likely to have a boy for their 8th child?
No, it's always a 50-50 chance no matter what. They even teach us that in biology.
That
It's
is
just that they
correct.
happen to have that tendency, but there's no factor that seems to have an outside effect. Therefore, it would always be a 50-50.
Thanks, Owen. There's always a 50-50 chance for every pregnancy. So, like I said, I tend to have baseball players who argue. I don't know what it is. I don't watch baseball, but with
Little.
what?
I have Cody on the phone here.
Yeah, does he believe in the law of averages?
If you believe in the law, he said he does.
See? Don't know what it is with baseball players.
What is this law of averages?
Ask her what the law of averages is.
What's the law? No, he can hear you.
I can.
What's the law of averages?
Averages?
So in baseball, if because they are a very statistic-based sport. I mean, all sports have statistics, but they have error averages, they have batting averages, they have tons of different ways to measure how the baseball player did. And so a lot of times with being up to bat, if they are, let's say, they have a batting average of 40%, but the last 3 times up to bat, they either struck out or they didn't get a hit, they were walked or whatever, they tend to believe that they're more likely the next time they're up to bat to actually get a hit, which is completely and utterly false. But baseball players have this like ingrained in their heads. Every year, baseball players argue with me about the law of averages, and I don't know why.
And you're due. You're using your due. Eventually you'll get a hit. You need to strike out 10 times in a row. You're due.
Oh,
Wait a minute, I
You
think I know what
don't.
it is. I think I know what it is.
what?
True.
So I
It's
think that it's out of like pure mental imagination. It's kind of like the orcs from Warhammer 40k. If enough of them believe that something is going to happen, it somehow finds a way of happening. So, I'm
So
guessing
you
that
say
that's
there's a
something
psychological effect to it, Owen?
What?
You think there's a psychological effect
Well,
that
I would say that to some degree it's also kind of like how you play like some of the hardest video games. If you believe that you could eventually become good at it, you put more effort towards it and you eventually find a way of doing it. But if you just keep losing and you believe that you're always going to lose, then it might affect chance to some degree, or maybe you just stop practicing as much, and therefore would not be as good. Or maybe that's something that they tell themselves so that way they keep trying to get better.
okay, but
I
that
think-
wouldn't affect the fact that
It
they
wouldn't be anything statistical, but it's
Right.
psychological.
right, it's psychological, but for whatever reason, like I said, I always have baseball players that are like, "Yep, the law of averages, it's a thing," and I'm like, "No, it's not."
Yeah, Cody has his last
not.
little bit to say.
Go ahead, Cody.
Okay. If you go 10 at-bats in a row, just striking out or doing whatever, getting out, eventually you're going to not get out. It's just, eventually you're going to get one that you don't get out eventually. It just might take longer to happen than other times.
Okay, so that's the law of large numbers, because as you have more and more repetitions, you're more likely to go to that single proportion, or like I said, they had a 40% batting average. So the more repetitions, yes, you are supposed to get closer and closer to your actual average or probability. What I'm saying is that because they struck out 3 times in a row, that the probability they get a hit on that 4th time up at bat is actually greater than 40%. And that's what the law of averages is saying, is that suddenly their probability of getting a hit is greater because they haven't done it the last 3 times.
Yeah, if you haven't gotten hit the last 3 at bats, and you're fourth at bat, you've seen all that you can see, and you're ready to go. So you're due. You're gonna get a hit, or you're more likely to. You've seen all that you need to see, and you're more likely to get a hit.
Okay. That's not true though, Cody. Are you saying because you've seen all their different types of pitches, the curveball, the fastball, the slider, all those different things, so you're ready and you're...
Yeah, your first year at bats, you struck out, but you saw all the pitches, you saw all the different pitchers, you got to adjust, and now you're ready. You come up to the plate ready to go.
Well, you are the first baseball player to explain it that way, but it's still not true. I'm sorry. You still only have a 40% chance of getting a hit. It's not more likely to happen.
I don't believe this will.
Well, you know what? Why aren't you in class? Maybe if you were actually on your own computer, you'd believe me.
I thought there wasn't Zoom. My computer said no Zoom today.
You have to refresh the page.
I did, like 3 times.
Actually, it never tells us when there is a Zoom.
It does. It says it in letters. It says no Zoom or Zoom.
It pretty much always says no Zoom today.
It says
I refreshed it, and it said no Zoom.
says Zoom today. Right there. Zoom
Right
today.
there. Look, Cody. That was-
I didn't see that. I saw no Zoom. Can you mark me a Zoom?
Yeah, today it says that, but
I suppose,
Open.
Cody.
there have been plenty of other times when it wouldn't.
What, Cody?
What?
I thought you said my name. Sorry.
Oh, yeah. So thank you, Miss Whittle, for
Oh,
marking me.
yeah. I even asked Ian if you guys were sharing a computer earlier. All right.
Oh, yeah.
We have 3 more questions. These ones I wanted you guys to do on your own. There's no like math to show, so even if you're not following along, you should be able to answer them. So if I call on you, you should be able to tell me your thoughts. So Shaquille O'Neal is a 50% free throw shooter. One week he shot 50 free throws. In one of the games, he made 6 free throws in a row. Was this a hot streak or did it occur purely by chance? Then question 2, which is more likely when tossing a coin 6 times? Heads, tails, heads, tails, tails, heads, or tails, 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 heads, heads, heads. And then true or false, Mr. Wilcox's brother-in-law has 3 girls. His next baby is more likely to be a boy because of the law of averages. So I'm going to give you about a minute. Like I said, there's nothing to show, so you should be able to answer me if I call on you.
Here's the second one.
And I'm going to give you a minute to think through what you think your answer is. And I'm going to call on somebody who hasn't talked yet today. Chance.
What?
Was Shaquille O'Neal on a hot streak or did it happen purely by chance?
By chance.
By chance. Hey, look at that. I chose Chance to give me the answer with his name in there. By the way, purely by chance is going to show up more and more often. And as I've said many times, I'm lazy. So if you ever see me write P, B, C, that's what I mean. Purely by chance. Okay? That little phrase is going to show up more and more. And so I get tired of writing it. Tanner! Which one's more likely to happen? heads, tails, heads, tails, tails, heads, or tail, 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 head, head, head?
The first one,
Why do you say the first one?
because I don't know, it looks more likely than the second one.
Okay. Jace, what do you think on this one? Are you there, Jace? No? Okay. Karina, what do you think on this one? Which one's more likely? Jake, what do you think's more likely?
I agree with Tanner.
You agree with Tanner.
I think it's more likely, but I don't think that the second one's impossible.
You think that's impossible?
No, I don't think it's impossible.
Oh, okay. You don't think it's
But I
never
think the
going to
first one's
happen?
far more likely.
Gotcha. Taylor, do you have a thought on this one?
I said they have the same likelihood because it's 50% every time you flip the coin.
Okay. Wooden, what did you say on this one?
I'm kind of confused.
So if I toss a coin 6 times, is it more likely that I'm gonna get heads, then tails, then heads, then tails, then tails, then heads? Or is it more likely I'm gonna get tails, 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 head, head, head? Did I clarify it all? I just repeated the question. I hate it when people do that. You're like, can you clarify? And they just repeat the question. I tried to reword it, but I don't know that I actually clarified. Yes, no.
Maybe the first one?
Okay, do you have a reason why?
No.
No? All right. Naomi, do you have which one you think is more likely?
I think they have the same likelihood.
Okay. Cameron?
I think it's the same.
Okay. Ace? Ian?
I think it's a stupid question, but it's obviously the same one. So,
Wow, thanks, Ian.
yeah.
Owen?
I guess same.
Same? Okay. Julia? The same? Okay. I think that's what you said. You kind of cut out. Sophie?
I think that they have the same likelihood.
Okay. And Leaf?
Since we're asking everyone today, the first one.
The first one. Yeah, I like to get everybody's input. And Chance, I'll call on you. I didn't call on you because you answered the first one, but what do you think, Chance?
Opposite of Tanner.
just to be the opposite of Tanner?
Yeah.
Okay. So I guess opposite means this one, right? Or did you mean same?
What's that one?
What?
The second one.
The second one. All right, well, all of you that said they are the same chance, that is true. They are equally likely to happen. Like Taylor said, I think it was Taylor after I talked to everybody, she said that because getting the probability of heads or tails is 50% all the time, So the fact that we got a heads there doesn't mean that we're more likely to get a tail. You can get 3 tails in a row and 3 heads in a row. They are equally as likely to happen. And then the last one, let's see. I'll try somebody who didn't answer me last time. Jace, are you there? Gotta love it when they turn on their Zoom and then zoom out. Karina? All right. Well then let's go with Cameron. True or false? Are they more likely to have a boy?
False.
False. Law of averages is not a real thing. Like Owen explained on the previous page, it's always a 50-50 chance with every pregnancy. So, any questions before I let you get started on your homework?
Why do people believe in the law of averages? It's just fake.
Well, it's kind of like this one here, like,
Superstition.
well that, and this seems hard to believe, even though probability tells us it's just as likely to happen as that one. When we think about something having a 50-50 chance, we would expect there to be some, back and forth between the two options.
Okay,
And
what about for number 2 if it was just straight heads for 6 times? Because that's still possible.
it is still possible.
So,
It would still have
Maybe
the
just
same,
different.
it would still have
Yeah.
the same probability, yeah. Because the outcome of this first toss has no effect on what happens with the next toss. So yes, any 6 options, permutations of heads and tails is just as likely as any other, which is hard for people to grasp for some reason. We think that because it's 50-50, we should get tails in there sometimes, but
yeah.
that doesn't always happen. It's when you do so many coin tosses that you get that perfect 50%. But like you saw in that applet, I want to say I was up in the 700s and I still didn't have 50% exactly. I'm
Yeah.
up at 900. I'm getting closer. But it's, let's see, now I'm below 50%. Last time I was
Yeah.
slightly above, now I'm slightly below. So it tells us what to expect, but it's never going to be perfect in reality. And I think that's why people struggle with probability. So.
Yeah.
So in there's a new module for Unit 3. And then today's date, we just went through the notes, and I just remembered I'm still recording. We don't need